Hello, and welcome to this lesson on the purity of substances. In today's lesson, we will understand that pure elements and compounds have specific melting and boiling points, and explore how mixtures have a range of melting and boiling points. Finally, we will learn how we can use these properties to determine the purity of a substance. So far, we've talked about purity in a chemical sense, and you're familiar with what makes a substance pure or impure. Building on this foundation, today's lesson will enhance our understanding by comparing and contrasting the behavior of pure substance and mixtures in terms of their physical properties. Let's begin by quickly recap what we mean by pure substances and mixtures. Pure substances consist of only one type of atom or molecule. In contrast, mixtures consist of two or more different elements or compounds that are not chemically bonded together. A common example would be saltwater. One of the key differences between pure substances and mixtures is their melting and boiling points. Specifically, pure substances have fixed specific melting and boiling points. For instance, pure water boils at exactly 100 degrees Celsius and melts at exactly 0 degrees Celsius under standard atmospheric conditions. On the other hand, mixtures, since they contain multiple different substances, do not have fixed melting and boiling points. Instead, they melt and boil over a range of temperatures because each component in the mixture has its own distinct melting and boiling points. As the mixture is heated, different substances melt or boil at different times, resulting in a gradual transition rather than a sharp change in state. We can illustrate this by considering saltwater. This mixture typically contains water and dissolved salt, usually sodium chloride. Unlike pure water, which freezes at 0 degrees Celsius, salt water freezes over a range of temperatures dependent on the concentration of salt. For example, seawater typically starts freezing around -2 degrees Celsius, and a very concentrated salt solution might not freeze until -21 degrees Celsius. This property is why we spread grit on roads in cold weather. The salt lowers the freezing point of water, meaning ice and snow will melt, even when the temperature is below 0 degrees Celsius. The ability to lower the freezing point and keep roads ice-free over a range of temperatures is a vital safety measure during winter. Let's look at another example. Petrol is a mixture of different hydrocarbons, and like saltwater, it doesn't have a single boiling point. Instead, petrol has a boiling range, which means its components evaporate at different temperatures. Typically, this range is between 40 degrees Celsius and 200 degrees Celsius. This boiling range is important for how petrol works in an engine. The lighter hydrocarbons in petrol evaporate and ignite easily at lower temperatures, which helps start the engine in cold conditions. As the engine warms up, the heavier hydrocarbons, which evaporate at higher temperatures, provide more energy to keep the engine running efficiently. This property allows petrol engines to function smoothly in a variety of climates and temperatures, making sure they perform well under different conditions. We can also use this difference between mixtures and pure substances to test for the purity of a substance. Suppose we have a sample of ice. We do not know whether it is chemically pure or not. To check this, we can gradually heat this sample, and if it melts at a precise, sharp temperature, in this case 0 degrees Celsius, we can conclude that it is likely pure. However, if the substance melts over a range of temperatures, this suggests the presence of impurities. The idea is similar when it comes to boiling points. By heating a substance and noting the temperature at which it starts to boil, we can assess its purity. A pure liquid, like water, will boil sharply at a specific temperature, such as 100 degrees Celsius, in the case of water. However, if the substance boils over a range of temperatures instead of at just one, it's likely a mixture of different components. Using these techniques, scientists can rigorously determine the purity of substances in laboratory settings. This has vast applications, including in pharmaceutical development, where the purity of a compound can determine its efficacy and safety. In today's lesson, we delved into the difference in melting and boiling points of pure substances versus mixtures. We explored how pure substances have specific fixed melting and boiling points, whereas mixtures melt and boil over a range of temperatures. We illustrated this concept through examples like saltwater and petrol, where the varying properties of these mixtures play crucial roles in real-world applications. We also learned that to determine the purity of a substance, We can use techniques like melting point determination and boiling point determination. Understanding these principles is not only crucial for academic purposes, but also immensely practical in real-world chemical analysis. Watch the rest of the GCSE chemistry course at Sophos Education.